Hi, everyone, and welcome. We are really excited to be here with you. And today we are going to speed up your microservices creation. We're going to show you a lot of things, a lot of magic. But before we are starting, let's start with a short introduction. So I'm Paz Janover. I'm the VP of Product Management at Application. Before Application, I led the product at Test Team and at Redis. I have vast experience as developer, as the team leader, and as a director of engineering in various companies. And I'm really happy to be here with you in this webinar.
Hi everyone, my name is Muli Gottlieb. I'm the VP of R&D at Application. Previously, I was VP at R&D at CloudShare, and previous to that, VP of R&D in Gigant, and been leading dev organizations since I think 2008, and a developer since probably 95. So I'm old. I'm very well connected to this topic, and this is the reason why I joined Application, because managing software teams and groups for so long, we all know the challenges of the modern world. It's very fast-paced. The stress for quick results only gets bigger and bigger. And when you have multiple teams, then you start having multiple ways of doing things, and then you need to reconcile and understand how different basic concepts were implemented in different teams. So we're going to see today how you can beat that challenge and how you can make things consistent and fast.
Great. So let me share a few words about Application. Application is actually the fastest way in the world to build production-ready backend services. With Application, you can auto-generate your code for everything, for your architecture, for your data models, for the API, the deployment, the integration, and much, much more. The only thing you need to do is only to add your business logic, but beside that, almost everything can be done and can be auto-generated for you. The code that Application creates is actually yours. We give it to you in the Git provider. You can customize it however you want, and the code itself is consistent, predictable, tested, and ready to deploy. So all you need to do is just to add your business logic and go to production. That's it. So I'm done with the sales pitch. Let's move on to see some real stuff.
Cool. So what we will demo today is we will demo how, of course, you create production-ready backend services in the fastest way in the world. The topic we chose just for the sake of the demo would be a stock trading system, but of course it can be any business domain. In this webinar, we only have like 1 hour including questions, so for the sake of time, we'll be very brief and minimal, but you are very welcome and invited to talk to us for a personal in-depth demo to go into more details. What we'll do today, we will build this demo gradually. So we will start with a single service with the CRUD operation for the data models. Then we will add some custom APIs on top of that. Then we will augment this example with another service and asynchronous service communication. And then if time allows, we look at how you can add advanced functionalities to your services using Application. So without further ado, the stage is yours, Paz.
Thank you. Okay, so for our trading system, we're going to create the first service. We're going to hit the add resource button and create a service. We're going to call it the stock service, which of course is going to be responsible for the stocks. I already connected the project to my GitHub, to my Git provider, and as you can see, I only created the relevant repo. And here I can choose which API I want my service to use or to expose. I have the GraphQL and the REST API, and I can choose one of them or the two of them. And also, I'm going to create the admin UI. Actually, it's very basic admin UI, but we're going to focus today on mostly on the backend and less on the front end. So I'm going to choose everything for my stock service. Here I can choose whether to create the service in a monorepo or polyrepo. Let's go with the mono configuration, and I can choose which database my service is going to work, whether it's Postgres, Mongo, MySQL, or MS SQL. Let's go with Postgres. I want my service to start empty without any entities. We're going to create the entities ourselves. And I want to also add auth module for the service. So let's hit continue. Okay, so now we're going to create the entities, the data models for the service, for the stock service. As you can see, it's that the user entity was already created. This is because of the auth module that we asked to create. And now we're going to start creating the entities. Let's start with this first entity of the stock exchange. Of course, for the stock service, we need the stock exchange. Here, I'm going to define the fields. As you can see, for every entity, actually, a few fields are created out of the box. The ID created and updated it. And I'm going to add a few more fields, of course. Let's say the address of the stock exchange and the name of it. So the fields were created. I can check and see that the type of the fields are set properly by application. Application actually try to guess the type of the fields. So for address, I have single line text. I can update it to multi-line text if I want. The name is chosen by application single line text, which is great. And we have the first entity. Let's move on and create the next entity. After we have the stock exchange, let's create entity of stocks. Sorry, stock. Okay. And the stock, and we're going to create the following fields for the stock for the stock entity. First, we're going to have the stock exchange in which the stock is traded. As you can see, before moving to the next fields, as you can see, application identified that we already have stock exchange entity, and actually application guessed the relation between the stock entity and the stock exchange. As you can see, the stock field is actually many to one. So as many stocks can be at one stock exchange, which is great. This is the actual relation that we want to have. We're going to have to add a few more fields. We have the ticket symbol. We have the share price of the stock, and we have also the total number of shares. Let's check the type of each one. So we see that the stock exchange, the relations is set properly. The ticket symbol should be string, which is great. The share price is decimal, which is also great. And total shares should be whole number. So let's update it to be integer. And that's it. The second entity was created. So now we have the stock exchange, and the user entity. Let's create the last entity for the stock, which is the company. Of course, we need to know the company for the stock, to connect the stock to company. So we're going to add the name of the company, maybe the headquarters. We're going to connect it to the stocks, and we're going to have also domain. Let's check that. So the name is single line text, which is great. The headquarter is single line text, which is also great. And I want to talk a few minutes about the stock field. So we actually, with the company, may have few stocks in few stock exchange. And as you can see, application actually identified that the one company can have multiple stocks. So the relation between the stocks and the company is set properly, and the domain is single line text, which is great. So let's see the entities. So we have actually 4 entities in this stock service. We have the company, we have the stock exchange, and the user. We can see the entities in an ERD display. So we can see all the entities and the relations between them and all the fields. So I think it looks good. The stock service is ready. So let's generate the code for all the entities and for the data models. So now application actually started to automatically generate the code for all that we have done. Just meanwhile, I want to show you the API. So as part of the code which is generated, out of the box, we create, actually application creates all the APIs, all the CRUD APIs and all the relations. By the way, the noise that you hear is that the code generation is done, but I just want to show you the APIs. So as you can see, we have here the list of all the APIs which are created for all the entities, all the modules actually. So let's see, for example, the stock entity. So application creates the following API, the CRUD API, or the regular APIs. In addition to it, it creates the API for the relations. So we have, for example, get stock exchange for the stock entity, which is great. So you can see we have all the CRUD APIs and the relations for all the entities. We can enable or disable a specific API if we want. So disabling a specific API will avoid generating the code for it. And one more thing that I want also to show you the DTOs. So again, out of the box, we create specific large set of DTOs for the CRUD APIs. You can see we have the relevant DTOs for the APIs. You can see that the order by input, the find unique args, and find many args and more. And one more thing before we are going to see the actual code, we can set permissions for the APIs. For example, let's go to the stock entity. We can set permissions. We can define whether a specific API is public, which means that it's unauthenticated at all. We can define all roles, which means all the authenticated user can access and use the API. And we can define a specific API as granular, which means that we can define which role can call API and access specific fields. As you can see, here we only have the user role, so we can define the role which can access the API and the relevant fields. Bully, do you want to show us the code?
So let's switch to my screen, and I'll show you the pull request that was created. So this is the repository that was connected earlier. There is one existing service here that is related to a later part of the webinar that we created in advance for the sake of time. But I will show you the pull request that was just created now. So you can see that this pull request was created 2 minutes ago by application. And this pull request includes all the service that Paz just created. What I want you to focus on as I guide you through the code is that we really focus on getting something which is production ready, full, tested according to all the best practices out of the box. So it's not just initial scaffolding or anything like that, or just boilerplate. You get a full service, and basically I'll show you in a minute, I can deploy this to production in minutes from now. And that's part of the magic here. We create the code already according to best practices. Of course, some of the best practices, as it is with coding, 3 coders have 5 opinions about how to do things. So those are our opinions about best practices, but we'll get to it later. We have an open plugin systems that can intervene in the code generation. So basically, you would be able to bring your own opinion and override our opinions or our best practices according to your best practices if you wish to do so. So without talking more, let's go into the code. So you can see, of course, this is the first bill of the service. So there are 311 files here, which is a bit overwhelming, but that is because of what I mentioned, the completeness of the service. So you get everything you need in order to get a fully functioning service. And as usual, the first build is very large. We will see later as we add smaller increments that we will get much smaller PRs that just update what you want to update. So you can see here, Paz created the stock service. He chose that he will have an admin UI and the actual backend service. We will focus on the backend service. That's what we focus on in application. So you can see off the bat that simple things like, I don't know, let me find it quickly. So you get the very basic parts from, for example, the repo README, which explains everything you got, including the environment variables and how to configure them and all the scripts you need to run in order to run this locally. You get the Docker file to run your service Dockerized in Kubernetes or wherever you want. So you can, like I said, very quickly go from there to production and just use this Docker file. We even give you, for dev purposes, a Docker Compose dev file, which for now only runs the database. And of course, it's expected that you run the service yourself. You have a Docker Compose, not for dev, that runs both the DB and the service. And later in the webinar, when we add more components like a message broker, you will see that those files also get updated with the code for running the message broker in your local dev environment in Docker Compose. So those are kind of like side parts. Then you can see we work in the Node.js code generation. We work with Prisma as the ORM. So you can see that everything that Paz defined in terms of the data models or entities, as we call them, is defined here in Prisma. Of course, later on, as we make changes, the code that you will get in the PR will also contain the data migrations for your services. So you will get a directory for migration, so everything is as code and according to best practices. And after we've seen kind of like the outer shell, let's dive deeper into the actual source code that we got. So you have a few utility parts here, like you have everything you need for authentication, for the login. So because Paz chose to create authentication, you get all the controllers to create the login, to create the user, etc. And I want to focus on the actual data entities. So just choosing an example. So one of those entities is the company entity. So you can see, for example, and I'll go through a few. So you got, for example, for REST API, you got the controller. The controller contains all the APIs that Paz showed you earlier, like create company and getting the list of all companies according to find args, so the filtering, and get a single company and delete a company, etc. And other than all the basic CRUD like update, etc., you can also see that, for example, here, so a company is connected to stocks, so you also get the methods for the relation, so find stocks, which returns the stocks related, etc. So everything you need. And this is the REST. You can see that the REST controller, is already created with all the Swagger decorators, meaning you will get a full Swagger UI if you want to experiment with it. And similarly to the controller, which is for the REST API, you also get a resolver for the GraphQL. So again, Paz chose to act with GraphQL as well. So both of them are wrappers to the actual service. So it's very similar to what I showed you in the controller, only in a GraphQL language. You can see also, and I will focus on that in a second, that everything is strongly typed. So again, according to best practices, all the args have a specific arg type, and we validate these args. So if a delete company needs the company ID, it gets the delete company args, which is part of what we generate here in the DTOs. So everything is strongly typed and validated. So that's part of the code you get, including the authentication, validation of the roles, meaning authorization, and the validation of the input itself. And both the controller for REST and the resolver for GraphQL, eventually, both of them, if I choose one of the methods, they call the underlying service, which includes the implementation itself. So this is where they join, right? Both the controller and the resolver will call this.service. The relevant method. And then in the service itself, You will get the implementation for all your CRUD operations. We will see later on how we can add methods that are not just CRUD, but for now, you can see that you got the actual CRUD implementation using the Prisma ORM and getting all those CRUD methods, including, like I showed you earlier, the ones for relation, including if I go to the, instead of company, to the stock part, stock. So you can see if I switch to the stock service, yep, please do load the diff, that for stock you have get company, get stock exchange, so all the connections basically that between the different entities. Other than all of that, you can see that, for example, for getting stocks, I have something called stock find many args. So let's look at that for a second. So stock find many args. You can see here that, like I said, everything is validated fully in terms of the input validation and the types. And in addition, so you have filtering. I'll show that in a minute, but you have filtering. So that's the where input. You have sorting, the order by, and pagination, so skip and take. So that's all out of the box, right? Authentication, authorization, filtering, sorting, pagination, all of those. What else? So if I'll take one of these and take the stock where input, so the stock where input allows me to filter according to the various fields of the stock entity. So I can, for example, if I want to find all stocks, well, maybe a stock isn't a good option, but for example, if on company I have something like domain, I can filter all the companies for a specific domain. So all of that is here, and as I said, strongly typed and easy to work with. You also get, let's find that. So
Muli, can you zoom in, please? Just it will be clear.
Okay, I can try. Is that better?
Great. Yes, thank you.
Right. Now I'm not seeing where I am anymore, but you can see that. It's okay. You can see that you also get tests out of the box. So in this case, you get tests for the controller, so API tests using Jest. So you even get the code tested. So as we keep repeating, production ready, tested according to all best practices. You get the tests, you get the code, everything you need. And basically, like I said, I'll zoom out for a second. This is a ready-to-use service. Like if I take the Docker file, build the image, and I already have all the scripts that are defined, explained in the README, I have all the scripts to build and run the service. I can build, create the image, go with the Docker file, and I can be in production in 5 minutes. So back to you, Paz.
Thank you, Muli. I think it's great to see this code which is made almost in no time. It's very important to emphasize that the code that you're seeing is in Node.js, but actually we know how to generate the code in TypeScript, Node.js, and .NET as well. So remember it. Now we are going to see how we can create custom APIs and DTOs. We showed you before that the application actually creates out of the box DTOs and the APIs, and now we are going to create a custom one. You're going to see that it's very easy and very intuitively to define DTOs and APIs in an application. And by doing so, actually you create single source of truth for all your data-related entities and actions. And of course, like everything in application, all the DTOs, all the action that you create and you create and define, you can get the code of it. So it's very easy and nice. We are going to have in this example, we're going to show you creation of an API for calculating total market capital of a specific company over all the relevant stock exchanges. In order to create this custom API, we want first to define in and out DTOs. The in DTO for such a custom action is actually the company name for which we want to calculate the total market capital. So we have actually out of the box relevant DTO for the input, which is a company-ware unique input. So we just need to define another DTO for the output. So let's define a special output DTO output for this. Let's call it company market capital output. Good. And let's say that we want to have the company name, the market capital, and let's say calculated rate for the time of the calculation. So we have the company name, which is a string. Great, we're going to have the market capital, which should be float. So as you can see, we can choose here which type for every field in the DTO. We have the DTOs. The DTO can contain other DTOs, and we have the primitives. So we need for it the float type. And as we said, we needed the calculated at for the time in which the calculation was performed. And for that, we, of course, need the primitive of daytime. That's great. So we have this DTO. We can see in the company DTO that the company market capital output DTO was created. And now we are ready to add action, to add our custom action for the company module, for the company entity. Let's call it company market capital. And great. So here we need to define the input DTO, the output DTO, and as we said, the input DTO should be the company unique, the company where, company where unique input. This DTO for the company name, and for the output is actually the same DTO that we just created, company market capital output. Great. So this is the output DTO regarding. So we wanted to have REST API and GraphQL API. And the method for our calculation, for our custom API is get. It's relevant, this is the path. And for input source, we are going to choose the params because we just need to have the ID of the company. And for the GraphQL API, we need to choose the operation type, which can be query or mutation. Of course, we need the query API, the query operation type. That's it. We are ready, and we just need to generate the code for the custom DTO and API. Muli, back to you.
Yep, so thank you, Paz. We'll wait approximately a minute for the code to be generated, for a new PR to be created. In the meantime, while Paz was talking, I already merged the previous PR. So now in the repo, you can see that under apps, we have the service that was pre-created that we will show in a minute, but I already merged the service that I just showed you earlier. So everything is here, and now I guess, like I said, in about a minute, we'll have a new PR. The focus here will be now that we, as I mentioned earlier, in the first PR, we got like 300 plus files, and this was for 3 entities. Sometimes, for example, we have a feature for schema import, where if you have an existing DB, you can introspect your existing DB, get a file with the introspection, and just import the entire DB at once instead of typing it one by one. So let's say if you import 100 data models, which isn't far-fetched for what our customers do, your first PR can contain something like, I don't know, 1,500 files, 2,000 files, etc. but that's just the first one. And what we will see here, that now, because we only added an increment, which is the custom API, we will only see this increment. I don't know how many of you saw before on our website, but our motto in application is just code what matters. And I think this PR will demo this. So we always say you don't need to waste time on undifferentiated heavy lifting, on boilerplate, just code what matters, meaning just code your own business logic, right? You don't really want to care about the rest of it, as long as you know that it's according to all best practices and that it's production ready, etc., which is what you get from application. And this will be a great example. So Paz added here the new operation. You can see that, for example, Paz defined the DTO. So you can see the DTO that was defined. Let me see. Wait, first I'll zoom in a bit, but maybe it will be easier to show it like that. Let's try. Yeah, that looks better. So I'll zoom in a bit so you can see that the DTO was defined, right? The market capital output with all the data validations. You can see now the changes in the existing controller, right? So the existing controller now import this and added a new method for company market capital, which, like all the rest controller methods, calls the service for this. So this is ready, no need to touch this. Similarly, in the GraphQL resolver, it imports what it needs, added a new query for company market capital, also calls the service with the args. And now we'll get to the actual service, and this is where it connects to what I just said about just code what matters. So, of course, we don't know the business logic that you wanted to create, so we create the method for you. We add a throw new not implemented exception so that you will know that this is your place to go and code what matters. So here is where you will add whatever you want to do with the calculation and the business logic. And our belief is that this is what you should be focusing on. And like I said, not wasting time on other things. What we can see here, other than what code we got, so like I said, it's a much smaller PR, it's easy to work with, and it's a good example of the continuous value that application brings. So unlike all kinds of boilerplate generators, which are used usually just once, so you run them once, you get some boilerplate, and then you forget about them, application is very different. Application is all about continuous value. So you work with the project, you bring your own code into it. In our language, we call it custom code. You work with application like it's another developer in your team. It's a very fast developer. It's maybe the brightest infrastructure developer on your team potentially, but it's another developer. This developer sends PRs. You can review the PRs. You can change them. I guess you can give a comment on the PR, but we will not answer. So that's up to you. But you can take these PRs and work with them as if you worked with any other team member that doesn't answer on PR comments. And then add your own code as you would in any normal development workflow. We have a very sophisticated Git merge strategy, meaning that we know how to merge the new changes that we bring with your code and never run over your code. Your custom code always gets preference, and we have a lot of, I don't know how to call it, but a lot of know-how about how to minimize conflicts. So we really do a smart merge, never override your code, minimal conflicts. If actually you change the same line that we are changing, so like I said, it's like another developer in your team, and that happens, right? If you have many developers, sometimes one of them would get a conflict because someone else changed that line, but it's not something which is different than anything you would do in your normal development cycle. And like I said, the emphasis here is about continuous value. So in this case, what we just saw can map to a specific feature request, right, from the product owner. He wants to add the company market capital. Great, new feature. I go to application, I add the external parts of it, the infrastructure of the API. The same can be maybe that I have the data models that Paz already defined, but now for a new feature, I need to add a field to one of them or add a data model. So I do that with application, and then I continue with my usual dev cycle. So it's all about continuous value and not just one-time creation. And basically off of that, you just need to go and, like I said, add your code here and you're done. So I'm going to go ahead and merge this and we can get back to you, Paz.
Thank you, Muli. So the next step is actually to make the project a little more complicated. So we want to add another service, and we want to add a communication layer between the services. So we're going to have some kind of event-driven architecture. So let's first dive into the second service. Actually, in order to save some time, I created the investment portfolio, the second service beforehand. So let's see just what we have here. So this is the service. It has two entities, the investment and the investor. Let's see the investment. We have the investment itself, the ID, the created add fields, the updated add fields, the default fields. And we also added investor field, which is relations to the other entity. One investor may have multiple investors, multiple investments. So it's one-to-many relations. We have the stock ID. The stock ID is actually a remote reference for the stock ID in the other service, bounded context for the stock. We have the quantity field, the value field, the value of all the shares in this investment, and we can see also the second entity, which is the investor, which contains the name of the investor, address, bank account, and investment, and relation to the investment. So this is the second service. So as you can see now, we have two services. We have the stock service and the investment portfolio service. And as I said before, we want to define the event-driven architecture, and we want actually to have the communication layer between the two services. So the stock service will publish changes in the share prices, and the investment portfolio service will consume the changes and update the investment value. In order to do so, we want to create a service broker. So we hit the add resource, we define the new message broker. That's it. The message broker is created, and for each message broker, we need to define topics. So let's create a topic named stock update or such. So we have this topic, and now we need to go to the two services and update them with the topic, the message broker, and the topic. And later on, we need to define the message broker provider for each one of the services. So let's go to the stock service, connect it to the message broker, which we just defined. Here we are in the stock service. So the stock service, this is the topic that we want to actually we want to send. As we said, we want to send the messages to this topic. So here we define the stock service and its relation to the message broker. In addition, we want, as I said before, we want to define or to install the plugin of the message broker for this service. Later on, Muli will explain better what plugins means exactly. So here we have the list of plugins, which is actually integrations to third parties software. So we connect the stock service to one of the message broker options. As you can see, we have Kafka, MQTT, Redis message broker, and more. Let's connect it to Kafka. So we install the plugin of Kafka. The same we need to do for the other service, the investment portfolio service. We need to connect it to the message broker that we defined before. However, here we need to define that it's going to receive messages from the stock option. And same as before, we want to connect it to the message broker, to Kafka in this example. And we are ready. And same as before, we hit the generate the code button. And Muli, it's all yours.
Thank you, Paz. So I'm not sure if we said it explicitly, but so the concept here is simulating a real-life scenario of async communication. So the stock service has the information of stocks, right? And then when the stock price changes, that service will know about it. It will post a message to the topic saying, yes, this stock has an update. And then the investment portfolio can pull from that, from Kafka, from the message broker, and update whatever it needs to update. For example, what is the value of each investor's stock portfolio or investment portfolio according to the changes in stocks. So a very simple example of a very clear real-world scenario of updating asynchronously between services. So now you can see that I got 2 PRs. Why did we get 2 PRs? Because this affected 2 different services. You can see this is updating the generated code for the stock service, and this is for the investment portfolio service. Of course, it's easier to work that way, where you have a PR per service, in the same way that maybe a different team works on stock service, etc. So each team will review its own PR. So let's start with the investment portfolio. So this is the side that is supposed to receive the messages from Kafka. So I'll be brief because I see we are starting to run out of time. So you get all the definitions of the Kafka broker. You get, as I promised, now the Docker Compose dev, and Docker Compose contain everything you need when you work locally to also run the services related to Kafka itself with Zookeeper and Kafka and the UI for Kafka. So it's very convenient to work on your local dev environment. Of course, adding the relevant dependencies. I'll skip over the non-interesting parts. I'll zoom in a bit. I keep forgetting. And then you can see we created basically all the boilerplate code or the scaffolds needed to add to this Nest.js service the Kafka and connect to Nest.js microservices. Oh, scroll, it's really bad here. We define for you a basic Kafka message. Of course, you can and you are expected to maybe change this to contain the key and value of the type of message that you want to have with your specific payload. And eventually, if I skip all the parts where it connects to the Kafka provider, etc. In the end of the day, the important bit is that you get a new controller which already uses Kafka and is already registered to the event pattern for the stock update topic. So this is a topic that Paz defined. You can see it's already registered to the topic. You have the on stock update. You get the message. And again, here, like I said previously, just code what matters. So you got the message, you have the message in hand. And now this is the part where you are supposed to add your own custom code, what you want to do with that message, save to DB, update something else, etc. So this is where you add your own business logic. So this is the receiving side. And let me go back and show you the other pull request, which is the sending side. I'll try to be quick. A lot of it is the same as what we've seen because that service needs all the scaffolds to run Kafka, so that is quite identical between both of them. You can see in the .env that everything is defined as variables that you can later change as needed. And then the interesting part here, which is a bit different because it's the sending side, is that of course you don't get a controller to listen because that's the sending side, but you do get this. You get a new service which has the emit message, which allows you to post messages. So you send the topic, you send the message. For example, you can decide that the message will have a payload like stock ID, old price, new price, and then from somewhere in your existing services, for example, I imagine that we showed earlier you have the CRUD operation for stock. So stock has an update function. And then when stock updates, I would call this emit message with updating the stock price between the previous price and the new price. And that closes the loop, goes to Kafka, etc. So that, I think, covers the parts of the code that are related to what we just saw with async communication and Kafka. And before moving back to Paz, I will use the time to say, so we just now installed Kafka, and you saw Paz going to our plugin library and choosing from a category called message broker. And there were several options, and you saw there are other categories as well. And that's one plugin that is currently installed. Actually, if I go to the same service, or one of them, you can see that behind the scenes, we actually got a a few more plugins already installed. So for example, wait, let me get the stock service. So Paz already defined in the stock service when he installed that he wants to use Postgres. So that's actually a plugin, and there are other plugins for other DB types. He chose that he wants to have authentication, so that behind the scene caused the authentication or the basic authentication providers to be installed. There are others. And now we chose Kafka, so we have that. So the concept here is, like I said in the beginning, we bring our own opinions about best practices, which is of course not our personal opinions. They are based on a lot of best practices that are well known, but still maybe your company has its own best practices or its own flavor of how to do something, how to connect to the database, how to do something that we do in a specific way and you want to do it in a different way. Or maybe you just need to add an integration to something we don't have, although you can see here the library is very big, right? So for CI/CD, you have all kinds of plugins that create Terraforms for you. For database, like I said, you have multiple options to connect to all kinds of database on-prem or in the cloud. You have options for caching, you have options for logging and observability. If you want to omit telemetry, for example, we had a very cool webinar about adding observability to your services recently. If you want to store your secrets, your passwords that your service will consume off of some key store, some cloud key store, we have integrations for that. So that is an open system. Of course, all the plugins are open source. We have documentation. You can use our plugins, but you are also welcome to write your own plugins, whether you want them to be published as community plugins or as private plugins. The plugins can intervene with every step of the code generation, meaning you can completely discard parts of the code generation that we do and do your own thing in the plugin, or take what we do and then modify it slightly in the plugin or add a new plugin for new integration. So that is your option to bring your own best practices, your own opinion. And of course, like I said, we already have a very large library of plugins and integrations, and you are very welcome to look into them and see the amount of options you have here. That's a very strong part of the platform. Before I move back to Paz, I will say one last thing before the closure, which was maybe unscripted, and I hope that Paz would not be angry with me. So Paz already said one of the things. You can see here that we generate code with Node.js, but we are also starting a .NET code generation, and you are welcome to look into that and talk to us if you have interest in that. And I can't say what exactly, but we have a very exciting launch and announcement coming next week. So I really invite you to stay tuned and follow us on social media, on LinkedIn, Twitter, etc. We will have a very, very exciting launch that really takes everything to the next level in terms of how to generate code, production-ready code in a whole new level and a whole new way. So I can't say more, but stay tuned next week. It's a really exciting announcement. And with that, back to you, Paz.
Thank you, Muli. I'm happy that you not revealed too much about our launch, our release next week. So everyone should be excited and wait for it. I just want to show you in a glimpse the status of the project that we created. As you can see, we created in the last hour or so more than 17K lines of code. We saved a lot of time and money, and also we saved or we avoided a lot of bugs. By the way, all the numbers here are according to some researches that we have done. And it's very nice to see the amount of code and the amount of functionality that we managed to create in the last hour. So let's summarize. During the webinar, actually, we try to show you how you can speed up your microservices creation using application. We managed to do a lot of things. We managed to create new backend services with data models, CRUD, and custom APIs. We installed plugins and added message broker. We defined event-driven architecture. and async communication between the services, and all was done in less than 1 hour, which is, I think it's incredible. We had a lot of discussion with our prospects and customers about creating backend services, and all of them actually reported that before application, it took them between 4 weeks to 10 weeks to create a backend service, one backend service, with everything, actually, with all the API, with all the data models, etc. And after application, after they started to use application, it took them a few hours. So I think it's very cool, and I encourage you to do it as well. And please note, again, I wanted to say it again, as Muli said, and I said before, that we have the code generated in Node.js and in .NET. Both of them are very in advanced stages, and we know all the best practices, and the code is very mature. So last thing before we're moving to the Q&A, if you have some questions, I want to encourage everyone to sign up to application. It's free. You're going to our website and go to the application. You can try all the capabilities, and we'll be very happy to hear your comments, to hear your feedback, and together we can improve even further the generation of backend services. That's it. Do we have any questions? Okay. Besides some celebration, I don't see any questions. So I think Muli was very clear, and it was very no need for any Q&A. But if you have any further questions, or you want to contact us privately, feel free to do it. We are available. We'll be happy to assist you in any question or request. That's it. Thank you, Muli.
Thank you, Paz. Thanks everyone.
Have a great day.